Today, we will be solving non-homogeneous differential equation by using method of undetermined coefficients. This method is very easier to use in solving non-homogeneous differential equation. So our aim for this method is to always look at g of x value, and we will always guess the particular solution for g of x. Thereafter, we will differentiate that guess equations and substitute it in our non-homogeneous equation. If we obtain a value for the undetermined coefficients, then our guess was correct. But if we cannot determine any value for the undetermined coefficients in g of x, then our guess wasn't correct at all. So in finding the general equations for non-homogeneous differential equation, we use the formula y is equal to yc plus yp. In this particular formula, yc represents the complementary solution, while yp stands for the particular solutions. Now, before we put this particular method into action, let us know how to guess the particular solution for g of x. If you are given g of x to be equal to any linear equations, like in the form x is equal to 2x plus 1, you can guess the particular solution to be equal to ax plus b. If you are given g of x to be a quadratic function, like this example, you can guess the particular solution of g of x to be equal to ax squared plus bx plus c. But if you are given g of x to be a cubic function, like this given example, you can guess the particular solution for g of x to be y of p equal to ax cubed plus bx squared plus cs plus z. But if you are given g of x to be equal to an exponential equation, you can guess the particular solution of g of x to be equal to e to the x power. Lastly, g of x is some function inside of x. You can guess the particular solution to be equal to y of p equal to a cos of x plus b of x. So this is the first and foremost thing you need to note in guessing your particular solution for g of x functions. Now, so let us consider the following examples and see how we can do our guess for the particular solutions. So we are given two functions here. We are given both f or e raised to the 7x, which is exponential function, and 6 here is a constant. But constant standing by itself we consider to be a linear. So this is a constant, we can represent it by n undetermined coefficients. So we're having two unknown functions. So we're having exponentials and we're having a linear function. So to guess the particular solution here, we would multiply the exponential equation by the linear function. And we know that in order for us to guess the particular solution for a linear function for g of x, we can say ax plus b. So the guess solution here will be ae to the y to the 7x plus b. The reason why we did not multiply e to the 7x by ax plus b because we will be multiplying two, or else say yes, we will be having two constants. So if we having ae to the 7x and we get ax plus b, we multiplying a by b, in which of course we multiply two constants. So we only consider one constant by saying ae to the 7x represent the particular solution for the exponential of function here, and yp represents the undetermined coefficient of this linear function, which is 6. Let's see our next g of x function given to us. So in order for us to guess the particular solution here, we have linear and we have exponential. So our guess solution here will be e to the 4x times as plus b. Remember again, we can put a outside or this particular parenthesis to multiply two constants. So the reason I wouldn't left this e in this particular form. So if we having g of x function to be looking at this, we will guess our particular solution to resemble this. Let's see the last one. We have quadratic and we have trigonometric in the form of cos. So for us to guess our particular solution here, we will use our guess particular solution for quadratic, which is a squared plus bs plus c. We'll use it for both cos and sine, but we will change the undetermined coefficients. So doing this, we have our particular solution to be as squared plus bl plus c times cos of x plus we have ds squared plus es plus f times sine of x. So what we did here, we only change the undetermined coefficients here. Since we use a, b, and c, we use d, e, and y, and f. But sine and cos remain to both. All right. So let's see this method. What we can do next. So after we have learned how to guess our particular solution, we should also know how to find our complementary or our homogeneous solution to the non-differentiate equations. The following rules are applicable. 1. If the discriminant b squared minus 4ac is greater than 0, then our complementary solution will be equal to c1 e to the r1x plus c2 e to the r2x. So for example, if we solve the characteristic equation and we have, let's say, minus 2 and 3. So this particular formula is applicable to find our complementary or homogeneous solutions. But if b squared minus 4ac equal to 0, if b squared minus 4ac equal to 0, it means that we will only get one answer if we do our factoring from our characteristic or our homogeneous differential equations. So we'll only be left with one value. So that value there, we'll use that value there to substitute it for error. So you observe that error 1, error 2, error 3, error 4, everything will be exactly the same. So in that particular case, we will use the formula YC, the complementary solution, equal to C1 e to the r1x plus C2x e to the r2x. But if b squared minus 4ac is less than 0, then we use this particular complementary or equations to find our solutions. So let's see our first problem. Problem 1. Now, when you are given problem like this to find a general solution for the non-homogeneous equation, the first and foremost thing is for us to make this non-homogeneous equation to be homogeneous. What makes this equation to be non-homogeneous? Because this differential equation is not equal to 0. G of x is not 0. So therefore, we'll firstly equate y prime prime minus 4y prime minus 12 to be equal to 0, making this equation homogeneous. Thereafter, we have to rewrite this equation in the characteristic form or the characteristic equation for this homogeneous equation. So the characteristic equation here is r squared minus 4r minus 12 equal to 0. We can easily factorize this. Factoring this characteristic equation, we have two real roots. So we can set each factor equal to 0. Then now we have r1 equal to 6 and r2 equal to minus 2. So we can see that b squared minus 4ac is greater than 0. So therefore, we use this particular equation to find our complementary solution. So doing this, we have C equal to C1 e to the 6x plus C1 e to the minus 2x to be our complementary solutions. We are now coming to guess our particular solution for g of x value. So we will be having 3g of x. Here we're having 3e to the 5x1. We're having sin of 2x2, and we're having xe to the 4x. So we're having three particular solutions. So this will be written in the form of g of x is equal to 3e to the 5x plus sin 2x plus x e to the 4x. So since we have three g of x values, we will also be having three particular solutions. So here our particular solution yp equal to yp of 1, yp of 2, and yp of 3. So we need to find yp of 1 using this. We find yp of 2 of 2x, and we find yp of 3 using x e to the 4x. We'll be guessing the particular solution for each of the g of x. So let us guess the particular solution for this. So since this is a linear and an exponential function, so we can guess our particular solution to be equal to a e to the 5x, leaving this a to be the undetermined coefficients. So since we having y prime prime, y prime, we can differentiate twice. So differentiating this particular solution twice, we'll differentiate for the first time, we have 5a e to the 5x. Differentiate for the second time, we have y prime prime to be equal to 25a e to the 5x. Now, we will be substituting the two or differentiable equations within this non-homogeneous differential equation, replacing y prime prime and y prime. When we see y prime prime, replace it by 25a e to the 5x. And when we see y prime, replace it by 5a e to the 5x. So doing our substitution now, we need to firstly or try to replace our g of x value, which will be equal to 3e to the 5x. So doing our substitution, it will yield to minus 4 times for y prime we have 5a e to the 5x, and we having y prime prime we have 25a e to the 5x. Then for y value itself, we have a e to the 5x. So doing our multiplications, we come up to 25a e to the 5x minus 20a e to the 5x minus 12a e to the 5x. All of these are like terms, so these values can be added or subtracted. So adding and subtracting this value, we will come to minus 7a e to the 5x equal to 3 e to the 5x. We can clearly see that e to the 5x will cancel e to the 5x, so we are left with minus 7a equal to 3. So dividing both sides by minus 7, we have a equal to 3 over minus 7 to be our determined coefficients. Since we have determined the undetermined coefficients, it means that our guess was quite correct. So we can replace this value of a within our particular solution to get yp of 1. So doing this, we have yp of 1 to be equal to minus 3 over 7e to the 5x. We can now go to find yp of 2. So now, finding our yp of 2 value, we will firstly guess our function. Since we have our trig function which is in the form of sum, so we can guess our particular solution to be resemble this. So whenever we have sin or cos to be g of x, we will always guess our particular solution in this form. So differentiating this particular solution twice, we differentiate for the first time, we have this value, and we need to differentiate for the second time. Doing our second differentiations, it will bring up to this particular value. Thereafter, we'll be substituting y prime of p1 and y prime of p2, y prime of p2 into our non-homogeneous differential equations. So doing our substitution, it will lead us to these particular values. So we can now do all our simplifications where we will cancel, we will add, or we'll subtract. So doing our simplifications, we will come out to minus 16b cos 2x minus 16c, or minus 16b equals 2f minus 16c sin of 2x plus 8b sin of 2x minus 8c cos of 2x equal to sin of 2x. We can see that in order for us to equate our coefficients, we only having sin on the right hand side. So all cos coefficients will be equal to 0. So only sin coefficient will be equal to 1, which is the variable 1 here. So doing this, we have on our right hand side 0 cos of 2x. We don't have no cos value yet. Sin 2 of 2x, we have in 1 here to be our coefficients. So doing our equating coefficients, so we will be having two equations. So we have our first equation here. So cancelling cos on both sides, our first equations to be equal to 8b minus 16c, or 8b minus 16c sin of 2x equal to the sin sin 2x. Then we have minus 16b minus 8c cos of 2x equal to 0 cos of 2x. So cancelling cos 2x and cos 2x on the side, and cancelling sin 2x and sin 2x on the left hand side. So doing this, we will come out to these two equations. Here's our first equations. So our next equation here will be this. So we can use elimination method to solve for our constant, our constant b. So solve for the constant b here, we have b to be equal to 1 over 40, which will be the undetermined coefficients for b. Then using b value and replacing it in any of the equations to solve for c, we'll have c to be equal to 1 over minus 20. So we can use these two constants now, we replace them within this solution to be our undetermined coefficients to get our second particular solutions. So doing this, we have yp of 2 to be equal to 1 over 40 cos of 2x minus 1 over 20 sin of 2x. So now we only need to find yp of 3. So finding yp of 3 now, we can also guess our particular solution to be equal to e to the 4x d of x plus e, since we have both exponential and linear equation. So we guess our particular solution because of this. We can try to eliminate this parenthesis to make life extremely easier for us. So multiplying, we will come out with these particular values. After our multiplication, we can differentiate twice. So differentiating this value here using the product rule, holding one constant, differentiating the other. So we want to y prime of p3 equal to de to the 4x plus 4dx e to the 4x plus 4e small e to the 4x. So differentiating for the second time will come out to this particular value. Since we have differentiated twice, we can now take each of the value and substitute it back into our non-homogeneous differential equation to solve for our undetermined coefficients. So doing this, we firstly simplify y prime prime. We kept the value here. So we added 4de to the 4x plus 4de to the 4x because these two are like terms to get 8de to the 4x. How we obtain the 8d to the 4x. So 16dx e to the 4x and 16e are not like terms, so they are not added. So substituting the value into our non-homogeneous differential equation, we bring out to this. So after we substitute our value, we do all our simplifications. So thereafter, we can see what we can cancel, what we can add like terms or subtract like terms. So doing this, we will come out to these values. So we can see that x e to the 4x appears on the right hand side only. So we don't have e to the 4x there. So we added 0 to be the coefficients. So equating our coefficients to solve for our undetermined coefficients. So we can see that we have minus 12d x e to the 4x equal to x e to the 4x. So e to the 4x will cancel e to the 4x on both sides. So after that, we can see that d now minus 12d will be equal to 1. Dividing both sides by minus 12, we will have d to be equal to minus 1 over 12. Since we have the value of d, we can now find the value of e. So finding the value of e, now we have our second to be 4d minus 12e, e to the 4x equal to 0, e to the 4x. So e to the 4x will cancel e to the 4x. So we have 4d minus 12e equal to 0. We have already calculated the value of d, replacing or substituting d value and solving for e. We have e to be equal to minus 1 over 36. Now, replacing these two undetermined coefficients to get our third particular solutions, we can do our substitutions. It will bring us to this value. We can also simplify this by factoring minus 1 over 36 outside here. So bringing minus 1 over 36 outside, we would be left with 3x, because 3x times minus 1 over 36 will give us exactly minus 1 over 12x. So we remove minus 1 over 36 and we only left with positive 1. So the e to the 4x is still remain outside here. So this is our third particular solutions. So we can now find our general equations now. So finding our general equation, we firstly need to get our formula to use, which is our general equation equal to yc plus yp of 1 plus yp of 2 plus yp of 3, because we have in three particular solutions. So doing our replacement now, or we have this to be our final answer. But we can still simplify cos and sin functions. So simplifying sin and cos function by factoring 1 over 40 also, we are left with this to be our final answer to this problem. So let us see our next problem and see how we can solve it. So let us see our equations now. So this is our second equation here. So the first thing again, we equate this to be equal to 0. The reason for this is that we want to make this equation to be a homogeneous equation. So since we have equated it to 0, we can now put it in a characteristic form. So putting a characteristic form, we have this. We can now factorize this particular equations by using synthetic divisions. So taking each of these coefficients, so we have positive 1, which is the coefficient for r cubed, minus 12, which is the coefficient for r squared, and positive 48, which is the coefficient for r, and minus 64, which is a constant. So we can try 4 to be our first trial. So on try 4, we bring 1 down. We say 4 times 1 is 4, minus 12 and 4 we get minus 8. So here 4 times minus 8 we get minus 32. So for the 8 and minus 32 we get 16. So 4 times 16 we get 64, minus 64 and positive 64 gets 0. Since this last part of this particular synthetic division is equal to 0, it means that our guess was correct. So x minus 4 is our first factor. We can now rewrite this in the polynomial form. So the power will be reduced by 1. So instead of r cubed, we get r squared, we get 1 r squared minus 8r plus 16 now equal to 0. So we can write this particular equation down. We already know that r minus 4 is one of our factors. So factorizing this, we will come out to these factors. So having three factors now, and we see that everything is the same. So equating everything to be equal to 0, we will see that r1, r2, r3, everything equal to r, because all of these values are the same, which is equal to 4. So now we can use this particular equation to find our complementary solutions, because b squared minus 4ac is equal to 0. So we use this. So substituting the value of r, we'll get this particular equations to represent our complementary solution. So since we have found y of c, we can now find y of p, which is our particular solution. Remember, in finding y of p, we need to guess y of p value. So we will have three particular solutions for this non-homogeneous differential equations. So we will have y of p1, y of p2, and y of p3 because we have 3g of x value. So let us see it for y of p now, because the y of p1 plus y of p2 plus y of p3, 3 y of p value. So we can use each of the g of x value to guess our particular solutions. So since this are constant, we can guess y of p to just be equal to an undetermined coefficient. So y of p1 now be equal to a because this are constant. So for this are exponential equation. So we can guess y of p value to be equal to b e to the minus 8x. And this is also our exponential equation. So we can also guess y of p to be equal to this. So we'll be differentiating each of our particular solutions one at a time. But what we observe is that c e to the full x is an element of y of c, which means c e to the full x can also be found within our complementary solution. Whenever you have any part of your complementary solutions to resemble your particular solutions, you need to either multiply or the equations by x squared or s cubed. It depends on how the equation will behave. So let's look at the example here. For our complementary solutions, we already have in x and s squared. So if we can multiply our particular solution by x, we will still have another part of the particular solution to resemble this because s appear here. If we multiply by s squared, we will also have another part of the particular solution to resemble our complementary solution. So instead of all multiplying by x or s squared, we'll multiply by s cubed. So we'll multiply the third part of y by s cubed. Because if we multiply the third part of yp by s cubed, it will change our entire particular solution. Because this part creates a problem for us. Because this part resembles this in y of c. So instead of multiplying by s squared, we'll still have this particular solution resemble this. So we multiply by s cubed. So multiply by s cubed, we will come out to this. Now we can now see that our particular solution is quite different from our complementary solution. So we can now do our differentiation. So doing our differentiation here, we have y of p1. So y of p1 is equal to a. So we can now differentiate our first particular solution. But a is a constant. So when we differentiate a, we will get 0. So y of p1 prime and y of prime prime, y prime prime of p1, y prime 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 of p1 will be equal to 0. We differentiate 3 times because the equations were in the third order, so we are having y prime prime. So that y we differentiated 3 times. So we can see that both y prime prime, and y prime 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 will be equal to 0. So equating this value into our non-homogeneous differential equation to solve for our undetermined coefficient a, we will come out to these values. So the first and foremost thing, we'll write our non-homogeneous differential equation down first before substituting this value here. So doing our substitution, we have minus 64a to be equal to 12. Dividing both sides by minus 64, we have a equal to 12 over minus 64. So we can reduce or deduce this particular fraction here. So reducing the fraction, we have our undetermined coefficient a now to be equal to minus 3 over 16. So since we have a, we can now guess our first particular solutions. So what of P1 is equal to A, but A is equal to minus 3 over 16. So we can move to what P of 2, which is our second particular solution. So we will differentiate 3 terms here. Differentiating for the first terms, we have minus 8p e to the minus 8x. Differentiating for the second term, by multiplying minus 8 by minus 8, we'll get positive 64. So y prime now we have 64p e to the minus 8x. Differentiating for the third terms, we'll say minus 8 times positive 64, we have minus 5 e to the minus 8x. Now, we'll be substituting each of these values within our non-homogeneous differential equations. So this is our non-homogeneous differential equation. So doing our substitutions, it will lead us to this. So let us do our modifications and do our simplifications. So multiplying and simplifying will give all these values. So we can do our equating coefficients now to solve for our undetermined coefficients. So here we can see that e to the minus 8x and e to the minus 8x will cancel out. So what we did there, we added all of these values because all of these values are like terms. So we have a negative, 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 negative. It is sound the same, you add. So we added everything, we came out to minus 1728 b e to the minus 8x power. So e to the minus 8x will cancel e to the minus 8x. So we are left, b will be equal to 32 over 1728. Because negative cancel negative, and we divided both sides by 1728. So we can also reduce this fraction here. 32 going to say 1 times 32 into 1728 equals 54 times. So we now have b to be equal to 1 over 54. So we can substitute this value into our second particular solution, replacing b, which is the undetermined coefficients. So we obtain yp2 will be equal to 1 over 54 e to the minus 8x. So we can now go and determine our third particular solutions. So using product rule again to differentiate yp of 3, we differentiate for the first time, we come out to this value here, holding one value constant, differentiating the others. So we differentiate for the second term, it will bring us to these particulars or values. So we are applying product rule. Remember to do your calculus 1 and calculus 2 before doing method of undetermined coefficients, or you can find my videos on differentiation and integration where you will learn how to differentiate and integrate. So differentiating for the second term, we obtain this, and differentiating for the third term and simplifying our value will bring us to these particular values. So since we having y prime, and y prime, we can now substitute this value into our non-homogeneous differential equations. So substituting these values into our non-homogeneous differential equations. So when we do our substitutions and simplifying, it will bring us to these particular values. So we can now simplify the values by correcting Latin, subtracting. Thereafter, we do our equating of coefficients. So doing this, we have cc e to the 4x to be equal to 2 e to the 4x. You can see that positive 72c x e to the 4x will cancel this, will cancel this, this will cancel this, and this will cancel this. So we only left with cc e to the 4x to be equal to 2 e to the 4x. So e to the 4x can cancel e to the 4x. So we have cc to be equal to 2 now. So we have cc to be equal to 2. Dividing both sides by 6 and reducing the fraction. So when we divide both sides by 6 and reduce the fraction, we have c equal to 1 over 3. So we now have our undetermined coefficient c, which is 1 over 3. Replacing that value, we have yp of 3 to be equal to 1 over 3x cubed e to the 4x. Now, we have our third particular solutions. So we can find our general equation by adding our complementary solution to our particular solution to get our general equations. So doing this, we have our final answer to be this. So let us see our final and last problem on method of undetermined coefficients. So this is our last problem. So we have y prime prime plus y equal to cos of x. So the first and foremost thing is for us to write this in a characteristic form, or we write the characteristic equation for this. Before doing this, we need to make the equation to be homogeneous by setting this to be equal to 0. So when we equal to be equal to 0, we have y prime prime plus y equal to 0. So writing this in the characteristic form, we'll have r square plus 1 equal to 0. So factoring this, we will have imaginary number r. So we can see that this is not a real number. So this we will have alpha and beta. So we have alpha to be equal to 0 and beta to be equal to 1. So we can now find our complementary solutions. So since alpha is equal to 0, we'll see alpha will place 0, we'll see beta will place 1. So doing our substitution here, we have e to the 0 because 0 times x will give us 0, and e to the 0 is just 1. So this particular value will vanish. So our complementary solution now will be c1 cos of x plus c2 sin of x. We can now guess our particular solution for this non-homogeneous differential equation. So since we are given a cos, we can guess our particular solution to be equal to a cos of x plus b sin of x. So differentiating these twice. But we can see that this particular solution also resembles our complementary solution. So we need to multiply this particular solution by x. So multiplying this by x because the same. So our particular solution is same as our complementary solution. Hence will be the case. So we need to multiply this particular solution by x. So whenever your particular solution and your complementary solution are exactly the same, you will always multiply either by x, s squared, or s cubed, depends. Alright, so multiplying our particular solution by x, it will bring us to y of p equal to as cos of x plus bs sin of x. This is our new particular solution. We can now differentiate this by using product rule. So finding our first differentiation, we will have this to be our first differentiation by using product rule. Differentiating for the second term, we will have this. So to be our second differentiable equations. So differentiated twice, we can now substitute these two differential equations into our non-homogeneous differential equations. So now, substituting this value there, we have y prime prime and we have a y. So doing our substitution here, we have this. So we need to simplify these particular expressions and we do our equating of coefficients. So simplifying these equations, so we have a to be equal to 0 because we can see that a is attached to sin and we don't have no sin on our right hand side. So therefore you find that a will be equal to 0. But b is attached to cos. So we're having 2b cos of x and we're having 2b cos of x, and you're having as cos of x. So here we're having cos of x, so we don't have no x here. So we're only dealing with cos. We are only equating the value with cos to be equal to 1. So this one get s cos, no, it will not be there. No, no, yes. So only this value will be equated to this. So we have a equal to 0 and we have 2b to be equal to 1. So solving for b here, dividing both sides by 2, we have b to be equal to 1 over 2. So now we can now replace our value, but you can find that a will go out because a is already 0. So putting a out, so we will have our particular solution to be equal to 1 over 2x sin of x to be our particular solution.